Hi Math, I'm Andy. In a previous video, I presented the paper cutting problem. This problem said that if you cut a piece of paper in half and then put those two halves on top of each other and cut those in half, you get four pieces. Take those four pieces, put them on top of each other, cut those in half, and you keep doing this. Cutting in half, putting on top, cutting in half again until you've made 20 cuts. I wondered, how tall would that stack of paper be? Now I started to do this in the video. I started to make cuts with my little safety school scissors, and it turned out that one, after a couple of cuts, the pieces of paper started to get pretty small, and two, I think about cut 7, I couldn't even get my scissors through it. I became frustrated, threw the papers in the air, and wished that I had done this mathematically, somehow making a data table. So I thought about that, and I did. I've come back to you with a data table about the number of pieces of paper left after each cut. So let's kind of go through this together. On my first cut, it looks like I have 0 cuts and 1 piece of paper. After I made my first cut, there's now 2 pieces of paper left. I put those on top of each other and make a cut, and now I have 4 pieces of paper. Put those 4 pieces, I make a cut, I've made 3 cuts, and I have 8 pieces of paper. Now I start to notice a trend with the number of pieces of paper per cut. It looks like that it's starting to double each time. So as I go down, I start to make more and more cuts, which becomes really harder and harder, and the pieces become smaller and smaller. And remember, we wanted to know what happens at 20 cuts. So it turns out if you're somehow able to make that 20th cut, you're going to have 1,048,576 pieces of paper left. It'll be smaller than confetti. And our question is, how tall will that stack be? I mean, paper is so thin, right? How tall could it be? Now, when you have a data table, it just seems good to acknowledge what the graph would look like. And I want you to notice this. This graph, it starts off very short, very small, right? At 1 cut, 2 cuts, you can barely see it because look at our Y scale. Our Y scale has to be really big because we need to register those really big numbers at the end. We call this exponential growth because you notice it starts off not growing very much and then it starts to grow a lot. Exponential growth is kind of what's happening as each thing starts to double. Now our question was, how tall would that stack of paper be? Well, let's take the number of cuts and let's think about the thickness of a piece of paper. So it turns out that, again, we would end up with 1,048,576 pieces. Now, I use standard printer paper, and standard printer paper is 0.004 inches thick. So naturally, we're just going to multiply these together. By multiplying these together, we end up with a value of 4,194.304 inches. Now, to visualize this is hard to say. So our answer would be it is 4,194.3 inches tall. But visualizing that really doesn't make any sense because I know there's 12 inches in a foot, and I know that there are 3 feet in a yard. And so because this is so many inches, maybe we should convert this to yards. And so like I said, because there's 12 inches in a foot and 3 feet in a yard, there are 36 inches in 1 yard. So what I'm going to do is I'm going to take this number and I'm going to divide it by 36 just so we have a better idea or a better picture of how tall this stack would be. And it turned out that 4,194.034 divided by 36 is going to be 116.5 yards. Now, that I can wrap my head around. I know a football field is 100 yards, including the end zones, which are 10 yards each. From goalpost to goalpost, a football field is 120 yards. So in a sense, if you take your piece of paper and cut it in half, and then cut that in half, and then keep cutting it in half, and you stack all those little confetti-sized pieces of paper up, you took a flat piece of paper and turned it in to a stack of paper almost the size of the entirety of a football field, including the end zones. So here we have the paper problem solution.